I'm here to teach you about the graphs of families of functions and how to find their domain, range, x-intercept, y-intercept, if the function is even or odd, to which axis the function is symmetric to, where the function is increasing, decreasing, or is constant, where the function has a minimum or maximum value, and lastly, if there are any vertical or horizontal asymptotes. It seems hard to do, but it's fairly simple. Let's check it out. Let me first define a few terms for you. An even function is, for every x in its domain, the number negative x is also in the domain. An even function reflects over the y-axis, and its equation is f of x is equal to f of negative x. To tell if a function is even algebraically, plug in negative x into the equation. Second, solve it out. Since negative x squared is the same as x squared, the equation ends up being the same as the original equation. If the new function is the same as the original function, that means that the function is even. An odd function is, for every number x in its domain, the number negative x is also in the domain. An odd function reflects about the origin, and the function is f of negative x is equal to negative f of x. The way you can tell if a function is odd is if you plug in negative x into the equation. If the resulting equation resembles that of the original one, if a negative 1 is factored out, then you know it's odd. So let's look at this equation. I plugged in negative x into the equation, and I get negative 2x to the third plus 4x. Then I factored a negative 1, and I got 2x to the third minus 4x. That's the same thing as the original function, because I factor out a negative 1. A constant function is when the x value goes up and the y value stays the same. A decreasing function is when the x value goes down and the y value goes down. And an increasing is when the x value goes up and the y value goes up. Let's make an xy chart for this absolute value function. I plugged in negative 2 and I get 2. I plugged in negative 1, I got 1. I plugged in 0, got 0. Plugged in 1, got 1. And plugged in 2 and got 2. Just by looking at the graph, I can tell a lot about it. First, it's reflective over the y-axis. That means that it's even. Second, the x-intercept is 0. The y-intercept is 0. And it's increasing from 0 to infinity and decreasing from negative infinity to 0. I also can tell that the domain is negative infinity to infinity because I can plug in any x value. But the range is 0 to infinity because y can't be negative because the absolute value doesn't allow for negative numbers. I also can figure out my local minima. Since my y value can't go beyond 0, then I know that my minimum point is 0, 0. For an identity function, we'll do the same thing. First, we're going to make an xy chart, plug in 3 values, and we'll plot our points. So I plotted these 3 points, and it looks like it can go on forever. That means that my domain is negative infinity to infinity because it has no limits, and my range is negative infinity to infinity because it has no limits either. We also can see where the function crosses the x and y axis. That's at 0, 0. So that's our x and y intercept. X is 0 and y is 0. Since the function is reflective about the origin, we know that it's odd. And the last thing we can figure out about this function is that it's increasing all the way. So next is the cube function. I made an xy chart and plotted these points and got a graph that looked like this. I can tell a few things about this. First of all, the domain is negative infinity to infinity because the x has no limits, as well as the range because the y has no limits. Second, the point that crosses the x-axis is at 0, and the point that crosses the y-axis is at 0. So our x-intercept is 0 and our y-intercept is 0. Third of all, we can tell about the symmetry. Since it's reflective over the origin, we know that it's odd. And lastly, the graph looks like it's increasing all the way. Now let's go to the square function. We know by looking at this graph that the domain is negative infinity to infinity and the range is 0 to infinity because the lowest point on the graph is at 0, 0. That makes our local minimum 0, 0. We also know that our x-intercept is 0 and our y-intercept is 0. Similar to the absolute value graph, this decreases from negative infinity to 0 and increases from 0 to infinity. The most obvious about the square function is its symmetry. Since the graph is reflecting over the y-axis, we know it's even. The constant function works a little differently when it comes to an x and y chart. Choose any number for b, and that will be your y value for any x value that you plug in. For example, I chose 2. I plugged in -3 and I got 2. I plug in -2, I get 2. I plug in -1, 2. 0, 2. It's all 2, and that means that my range can only be 2. This function is called a constant function because it doesn't increase or decrease. It stays constant for the entire time. But this function still has symmetry. It's reflected about the y-axis, and therefore it's even. Although my range is limited to b, or 2 in this case, my x value can be any number. So my domain is negative infinity to infinity. Next, we have the cube root function. I made an xy chart and I plugged in these values, and this is what the graph looks like. Looking at it, I can tell that the domain and range are both negative infinity to infinity. They have no limits. The y-intercept is at 0 and the x-intercept is at 0. Although this graph looks a little funny, it still has symmetry. It's reflected about the origin, and that means that it's odd. This is a reciprocal function. Different from the other graphs that we've looked at before, this one actually has an asymptote. In fact, it has two asymptotes. One when y is equal to 0, and 2 when x is equal to 0. Because of our asymptotes, our domain and range are limited. For example, the domain is negative infinity to 0 and 0 to infinity. Our range is also negative infinity to 0 and 0 to infinity. The reciprocal function is symmetrical. It's symmetrical to the origin, which means that it's odd. This graph decreases from negative infinity to 0 and increases from 0 to infinity. There is no x-intercept, nor is there a y-intercept. This is a square root function. If I set radical x to greater than 0, I'm going to get the domain. But it has to be greater than 0 because you can't take a square root of a negative number. The domain is therefore 0 to infinity, including 0. The range is from 0 to infinity. The graph of a square root function increases from 0 to infinity. The graph crosses the x-axis at 0 and the y-axis at 0. So the x-intercept is 0 and the y-intercept is 0. The local minima, which is also the absolute minima in this case, is 0, 0. There's no maximum because the graph increases from 0 to infinity. Now you know everything about the graphs of functions.